Okay, so in this part we are going to continue looking at moles, but we are going to now look at doing calculations with moles and some of the calculations we do in chemistry using the mole concept. Let's get into it. Okay, the first thing we need to be able to do is convert moles, number of moles, into the number of actual particles, so the number of atoms or molecules. So just as an example here, if we have 0.20 moles of carbon dioxide, how many molecules would we have? Well, we would have, if we have 1 mole, we would have 6.02 times 10 to the 23 molecules. That's from our definition of a mole. I think I forgot to say this in the last slide. We call this number here, 6.02 times 10 to the 23, Avogadro's number. If you watch the video, which hopefully you have, you would have that would have been explained to you. You don't really need to know why it's called Avogadro's number, but it is interesting to know that history. I encourage you to have a look at that, but don't necessarily need to remember that's what it's called, although we do use it a lot. Sorry, I digress because I forgot from before. So how do we work out 0.2 moles? Well, if there was 1 mole, there would be that. So if we've only got 0.2 moles, then it's 0.2 times 6.02 times 10 to the 23, which is equal to 1.204 times 10 to the 23 molecules. So if we had 0.2 moles of carbon dioxide, we would have 1.204 times 10 to the 23 carbon dioxide molecules. In the next one, slightly more complex, but shouldn't be too bad. How many atoms would we have there? Well, what we basically mean by carbon dioxide is that we have 1 carbon atom and 2 oxygen atoms, which is 1 plus 2 is equal to 3 atoms. So in each carbon dioxide we have 3 atoms. So if we want to know the total number of atoms, that's going to be equal to 3 times 0.20 times by Avogadro's number, and that will be equal to 3.612 times 10 to the 23 atoms. Now we could have just gone straight from that step there to there and gone, well, that's how many molecules. There's 3 atoms in each molecule, 1 carbon and 2 oxygen. So 3 times 1.204 is equal to 3.612 times 10 to the 23. I've just done the full working out to get that there. So hopefully that shows the conversion from number of moles to particles, and hopefully that is fairly straightforward. Cheers. So the next thing we need to be able to do is calculate the molar mass or the relative formula mass or the average formula mass, whichever terminology you want to use, for various molecules, or in this case ionic compounds with calcium hydroxide. This is a fairly straightforward process where we use the periodic table. So in the first case here, for hydrogen, we have 2 hydrogen, so we go 2 times the molar mass of oxygen, which is 1.008, plus oxygen, which is here on the periodic table, which is 16.00, and if we add those up, we get 18.016. And what is that? That's a measure of grams, and if we want to put a unit, grams per mole. So every mole of H2O weighs 18.016 grams. If we were going to do the next one here, which is sulfuric acid, H2SO4, that would be equal to 2 times 1.008 plus sulfur, which is 32.06. So we just read these from the periodic table, plus oxygen again, and I guess the hydrogen came for that one as well, plus 4 times 16.00. We'd put that all into our calculator and get 98.076 grams for each mole of sulfuric acid. Hopefully these are almost boringly easy. We'll just do one more though. Calcium hydroxide. So we've got calcium down here, 40.08, and obviously oxygen and hydrogen here and here, which we've already used. So we've got 1 calcium, so that's 40.08 plus. Now, we've got 2 OHs here. So I'm going to do this with brackets. That's what the little 2 in the brackets mean. So 2, what is oxygen? What is hydrogen? 1.008 plus 16.00. And we can plug that into our calculator. And we will get 74.096 grams per mole. So that is calculating atomic mass or molar mass or relative atomic mass. Hopefully that's very, very simple, but if you do have any troubles with that, please sing out or check again over this video. Let's move on to the next bit. So finally, we need to be able to convert between moles, which we give the symbol N, mass, which we give the symbol little m, and when we deal with mass in chemistry, we are usually dealing with mass in grams. And to do both of those, so this formula here converts mass into moles, and this one converts number of moles into mass, so it does the opposite. And this is just this formula rearranged. We use the capital M, which is our molar mass or our atomic mass or our relative atomic mass or whatever we would like to call it. So, firstly, these formulas, I'm hoping that you can see that this is the same formula, just rearranged. I really don't like to use this, but I know some people like to use the triangle to remember how to rearrange these formulas, where you go N equals M over M. So if you want to know the number of moles, that's equal to M on little m on big M. If you want to know the mass here, that's equal to N little n times big M, N times M, which is this formula. And we don't ever really work out the molar mass with this formula, but that would be equal to mass over number of moles. But that's not a conversion we usually use. I prefer to use the proper algebra. So if we want to go from this formula to this formula, we want to get rid of the... so if we want to go from here to this formula, we would want to get mass on its own, so we want to get rid of the molar mass. So we times both sides by molar mass. M over M cancels, mass equals number of moles times molar mass. That's the proper algebraic way to do it. That's the cheat triangle way. I'm not sure which way you've learnt. I like the proper algebra. Okay, but for now I've given you those 2 formulas anyway. So let's do this first one. How do we convert grams to moles. And let's say we've got 10 grams of calcium hydroxide. That means that the mass is equal to 10 grams. The molar mass is equal to, we just worked that out on the previous slide, which is why I've chosen that, which was 74.096. You could go through and work that out again if you weren't sure. So the number of moles is equal to the mass over the molar mass, which is equal to 10 divided 74.096, which is equal to 0.13 moles. Now, I've quite intentionally there only gone to two significant figures, 1, 3. So the last, if you like, two figures are our significant figures, because our mass here was only given to two significant figures. We did know the molar mass to 5 significant figures, 1, 2, 3, 4, 5, but when you work out an answer, you should give it in equal to the least number of significant figures of the information you were given. So this information here we were given was given to 2 significant figures, 5 significant figures. So because there was a 2 there, we should only go to 2 significant figures in our answer. We'll keep coming back to significant figures, so don't get too stressed by that. The main thing is here that you can work out the number of moles given the mass and the molar mass. Now let's look at going the opposite way. What about if we know the number of moles? So in this case, we know we have 0.10 moles of sulfuric acid in this case, and we want to work out how many grams of sulfuric acid 0.1 moles is equal to. Once again, we start with the info in the question. The number of moles equals 0.10. The molar mass for sulfuric acid, and I'll just do this. Often, particularly in a question where we've got lots of things, we would do this, molar mass of sulfuric acid. It's just a practice to get into for later on, is equal to 98.076. I'll just check back on the previous slide. So the mass of sulfuric acid would be equal to, hang on, do all the steps, the number of moles times by the molar mass, which would be equal to 0.10 times 98.076, which would be equal to 9.8 grams of sulfuric acid. Once again, two significant figures, because we only had two significant figures here. That was our least number of significant figures. So hopefully now you can see how we convert between moles and mass using the molar mass in both directions. So that should set you up to work through all of the next set of questions looking at quantities of atoms. I think it's called it in the book, but I prefer just to stick with the title moles. That's the really important concept here. Thanks.